So here is our video on 3A, or sorry, actually 3B. We already did 3A, so I'm going to do all of these things for this equation right here. This is a little bit more complicated than the previous one. We will jump right in, though. What I want you to notice is that A is equal to -2, B is equal to -10, and C is equal to -9. We're going to use some of those things. Remember, ax squared plus bx plus c is our general form for a quadratic. So you should know that to find the vertex, the x value of the vertex, x is always going to be minus b over 2a. So what we're going to do is use this a value and that b value in this formula right here to find the x value for the vertex. So let's go ahead and do that. When I plug those values in, I get my b value is -10. So I get, oops, let me flip over this. Negative, and then I get my -10 in the top over 2 times -2. What I want you to see here first is that I've got 3 negatives. So two of those negatives will cancel each other out, and then the other one will be remaining. So my overall answer is going to be negative. And then I'm going to have 10 over 4. That simplifies down to 5 over 2, but negative. So that tells me that, and then actually I can write that as a decimal if I want. That is equal to -2.5. So the vertex is at -2.5, comma, I need to figure out the y value. So to figure out the y value, what I need to do is, in this case, I need to take this -2.5 and plug it into that equation right there. So let's go ahead and do that. All right, I'm going to zoom over here a little bit. So I get f of -2.5 is equal to -2 boink boink squared. My -2.5 goes here. And then I get -10 times -2.5, and then -9. So I'm going to show out some of the work for this. I'm not going to show it out for all the ones that we're going to do later. But what do we get? We get -2, times a positive 6.25. That is positive because we have a double negative when we square this right here, so that goes to be positive. Minus, there's a double negative here, 10 times that. It gives me a plus 25 when I multiply 10 by 2.5. And then I get my -9. That is 2 times 6.25 is a -12.5. Plus 25, and then -9. And if you simplify all that out, we wind up getting 3.5. So that's going to go in right here. So I'll erase this, and I'll make that a 3.5. Hopefully that makes sense. You know, the work to do this math right here is kind of long, and you know, seems reasonable to use a calculator to do some of that arithmetic, especially with those decimals. All right, so let's keep going. Once we have the vertex, we know the axis of symmetry is just the x coordinate of that vertex. So I can just write x equals -0.25. And you know what I'm going to do right now is I'm going to come down here, and I am going to put a dot at let's see, we got 1, 2, 3. So that would be -2.5. And 3.5 would be up there. So up 1, 2, 3, and then a half unit right there. So what I'm going to do is put a dot here and there. I'm going to put V for vertex, and then I'm going to actually write the coordinates. Maybe I'll do it in red so we can see it a little bit better. Negative 2.5, comma, 3.5. And why do I write it above? Well, I can look at this parabola, and I can see that I've got a negative number there. So we sometimes call this, it's been dropped. So it opens down like this. So if I write the V up there, then it won't be in the way when I go ahead and graph my function. So I'm just going to sketch something that I am eventually going to erase. You might not want to draw this because I'm going to erase this and make a more accurate version. But I know that that graph's going to look something like that right there. So I'm drawing that there because I want to use it to answer these three questions right here. Does it have a min or a max? Well, since it opens down, we know that this thing has a max, as we can see right there. So we're going to write max. What's the domain? Well, it is negative infinity to infinity. It is, or we can say all real numbers. Either of those are good, or you could even write out all real numbers. We talked about that in part A. And then the range. Well, notice it shoots down to infinity, but if we were to talk about, it has a high point right here. The highest value, the highest y value here is going to be that right there. So how do we write that with interval notation? We write negative infinity, comma, and then the highest value it gets to is 3.5. And I put my parentheses, and that's the range. So hopefully you're okay with that. And now I'm going to erase that green thing that I drew, and we're going to fill it in more accurately. So the last thing that it asks us to do is to include at least 5 points. So we need to get some, I erased that green one. We need to accurately put in what this parabola looks like. So what we need to do is figure out some values. So the easiest way, I think, to do this is to make a little table of values. And I'm going to make my x's. I'm going to say y equals negative 2x squared minus 10x minus 9. Now, we already know from the work in red above that at x equals negative 2.5 that we would have a y value of 3.5. Now, I want you to think about a number line and negative 2.5. What two numbers is negative 2.5? What two whole numbers or integers is negative 2.5 between? Well, negative 2 would be above it, and negative 3 would be below it on number line. So that would be this coordinate and this coordinate. To me, since we have some flexibility, it says it include at least 5 points. It doesn't specify what points. I'm going to go ahead and figure out those points. Now, there's lots of other points that we can figure out, and you could do those. So there's a little bit of an open-endedness to this. So what I'm going to do is write negative 2 and write negative 3. And then what I need to do is figure out the values of this equation right here, which I have written right there, at those two x values. So we're going to plug it into these. So you can see here I've got it worked out for us. I just plugged in negative 2 for all these. So this winds up giving me a negative 2 there, negative 2 there. If I work this out, we wind up getting negative, negative 8 plus 20 minus 9, which gives negative 3. So you would want to do that for this negative 2, and you would also want to do it for the negative, or sorry, not negative 3. It's just a positive 3. You would want to do that for this value, and 2 more. So you wind up getting 3 for this one as well. And why is that? That's because of symmetry. I think you'll see this. So I'm going to draw a dot at this spot right here. And then remember, we get a line of symmetry right down here. So since we have a line of symmetry at the vertex, remember our axis of symmetry, I know that once I have that point over there at 3, I also have this point over. Now for the last one, I'm going to actually take advantage of that symmetry and try to find the easiest points possible. If you look at this equation right here, it would be really easy to plug in 0 and 0, and that gives me just -9. So I'm going to go ahead and do that. I'm going to plug in 0, and that gives me -9. So I can go to 0, -9, count it out, 1, 2, 3, 5, 6, 7, 8, 9. So we know it passes through that point right there. And then let me take that line of symmetry, which goes here, and I'm going to go over that same amount, which puts me right here. So now I can just draw my parabola in like this. I can try to draw it. Like that. And then it has the good, perfect steepness. We've got 5 points. It's kind of a long problem. A little messy with the decimals. If we didn't have decimals like this, it'd be a little bit easier. All right, so hopefully that's good. Thanks, bye.